Okay, these notes are pressure and temperature conversions. So let's look at equivalent pressures. The air pressure at sea level is 1 atmosphere. This is used to compare all the other units of pressure. So 1 atmosphere equals 101 kPa, which is also equal to 760 millimeters of mercury, which is also equal to 760 torr, which is also equal to 14.1 psi, or pounds per square inch. Now, to convert pressure, we'll need to use dimensional analysis. You can either use a picket fence, which is what I usually do, or 2 equivalent expressions, which is what Mr. Mefford does. So I'll be using both methods to solve the problems, and you can use whichever method you're most comfortable with or that you understand the best. Okay, so let's express a pressure of 1.4 atmospheres in millimeters of mercury. Well, the first thing we're going to need to do is find our conversion factor. So we have atmospheres and millimeters of mercury. So when I look at that list from the couple slides ago, I know that 1 atmosphere is equal to 760 millimeters of mercury. And these are the two, this is the conversion factor I'm going to use. So let's do a picket fence first. So we're going to take the 1.4 atmospheres, and we're going to put 1 atmosphere on the bottom and 760 millimeters of mercury on the top. Okay? And when we multiply 1.4 times 760, we get 1064 millimeters of mercury. Now let's do it with the 2 equivalent expressions. So I'm going to pull my thing up a little bit. So I'm going to take 1.4 atmospheres, put it over 1, and now this is where I put my conversion factor. Now we're going to put the 1.0 atmospheres on the bottom, because remember, we need to cancel the atmospheres that are on top. And then we're going to put the 760 millimeters of mercury right there. So when we multiply, we get 1064 millimeters of mercury. And as I said, you can use whichever method works best for you. Okay, so we're going to express a pressure of 770 millimeters of mercury in kilopascals. So the first thing we need to do is we need to find our conversion factor. So we're looking at millimeters of mercury in kilopascals. So we find that 760 millimeters of mercury is equal to 101.3 kilopascals. And that's what we're going to use in our picket fence. So we're going to take 770 millimeters of mercury. Okay, and then we need to put our conversion factor here. So the 760 millimeters of mercury goes on bottom. 101.3 kilopascals goes on top. Now this time we're going to multiply 770 times 101.3 and divide it by 760. And when we do this, we get 102.6 kilopascals. Now let's do it using equivalent expressions. So 770 millimeters of mercury over 1 times, and we're going to put the 760 millimeters of mercury on the bottom, 101.3 kPa on top. Those cancel out. We get 102.6 kPa. Okay, and you can do it with any of them. We've got 5 conversion factors. We can go from psi to millimeters of mercury. We can go from torrs to atmosphere. Whatever you want to do, you just need to know which conversion factor to use. So you just have to pick out the 2 numbers that you're using. Okay, temperature conversions. When you're doing gas laws, you have to do all the math using Kelvin rather than Celsius. That's because Kelvin does not have negatives. Celsius does. You can have a negative 100 degrees Celsius. You can't have a negative Kelvin. And in fact, absolute 0, which is the temperature at which nothing moves, period, everything is dead, is 0 K. In fact, there's nothing out there that we know of in the universe that's at 0 K. In case you don't remember from ICP, or if you didn't take ICP, basically temperature is a measure of the kinetic energy molecules have. So when you put a thermometer in something, it's measuring the amount of kinetic energy. And even at 1 Kelvin. There is some kinetic energy. Very, 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 very little, but there is some. When you hit that 0 Kelvin mark, there's absolutely no energy whatsoever. There's no kinetic energy. Nada, zippo, zilch, dead. Okay? So when we're doing gas laws, we don't want to have negative pressures. You can't have a negative pressure or negative volume. And so we have to use Kelvin, which doesn't have negatives. Okay, so in order to convert, we need these two things. So if you're going from Celsius to Kelvin, you've got to add 273. And if you're going from Kelvin to Celsius, you subtract 273. Okay, so what is 125 degrees Celsius in Kelvin? So we're going to take our K equals 125. Now remember, it's degrees Celsius plus 273. And when we do that, we get 398 Kelvin. Now notice there is no degree symbol by Kelvin. Kelvin doesn't have degrees. It's just 398 K or 398 Kelvin, not 398 degrees Kelvin. Okay, there is no such thing as degrees Kelvin. Okay, what is 126 Kelvin in Celsius? So this time we're going to take our Celsius. 126 minus 273 gives us negative 147 degrees Celsius. Whew, that's gold. But once again, you notice that negative is Celsius. Celsius can be negative. We don't want to use that in the problem itself. The only time you convert back to Celsius is if the problem asks you to. Okay, otherwise we can keep it in Kelvin. If you have any questions or have any issues, we're going to do some practice problems after this. I'll probably put a warm-up up on YouTube also, and I'll give that link to Mr. Mefford so he can put it up also if you guys want a little bit more practice watching me do a little more practice. But otherwise, if you have questions, get a hold of either Mr. Mefford or I, and we'll try and help you. Okay, bye.